Basically, our main goal is to figure out new and innovative ways to drive down the cost of going to space or increase the ease of access to space. Um, as sort of kind of embodied in our name, SED stands for the Students for the Exploration and Development of Space. Right now, we got two really big projects going on. One being the CubeSat, which is kind of what we're talking about here today, and the other one being our Vulcan 1 rocket. We're trying to be the first students in the world to design or to launch a rocket powered by a 3D printed engine and be the first in the world to recover it. The competition, just as a little background, is it's a $3 million competition set up through NASA's Centennial Challenge. And basically what we're competing to do is we're competing against other teams and companies all across the United States to try and secure a spot on NASA's new most powerful rocket, the SLS. And we're trying to we're trying to land within the top three teams to get onto this rocket, which is going to the moon. They're going to let us go, and we have to slow ourselves down into orbit around the moon, and then we have to stay there for a year, sending back some signals. And so what that means leading up to it and how you get a spot on this rocket is we have to place highly in the 4 ground tournaments. So when we started this competition a year ago, it was myself and then the project manager, Faris Hamdi. We sat in a room and we basically begged the question, what is a satellite? We had absolutely no experience with satellites. We were freshmen coming into college. We just thought this was a cool opportunity that we wanted to pursue. And so not very surprisingly, we were going up against a bunch of Ivy League schools and teams that have a ton of experience with satellites and companies. We were huge underdogs, and it showed in our first ground tournament where we placed second to last out of 20 teams. In this last ground tournament, I'm really excited to say that we got third place, just behind MIT and Cornell. And MIT and Cornell have big professors who've launched satellites before. They have big lab spaces, all graduate students working on it. We're a team of strictly undergraduates led by a few second-year students. So we had to go down to the industry and help find sponsors like MTI to help us get this thing done. I actually met Gary Cosmer, who's the CEO of MTI. I met him a couple of times at a couple different conferences. I got his email, we set up some contact, and they agreed to help us print off our engine for the satellite. And by the way, I'm proud to say that in our satellite design, NASA said that one of our greatest strengths on the entire satellite was our engine design and the innovation that it brings. It's really, really exciting. When we won GT2, I think that was the most exciting day of my life. Because we're huge underdogs in this competition. The nice thing about additive manufacturing is we could do all the designs in the computer, and then we could send it over to a printer, and it gets printed. Really the big benefit of it is it drives down the cost of developing these engines, because before, you imagine you have a bunch of technicians and engineers who are building these complex engines, and it takes a lot of man hours. It becomes very expensive because of that, and ultimately it limits what we could do in space, because as the cost goes up, less people are willing to pay that heavy price. So it brings the cost down and the time down for which you can get a new engine. And another cool thing that'd be exciting in the future is that, let's say we go to the moon or Mars, we can print some of these stuff just when we're there. If we send over a 3D printer, you could develop things on the moon or Mars or whatever. But beyond that, we're also able to produce geometries and designs that were never possible before, because you can get very complex with these designs because you're just printing it. Whereas before, you have to say, you take a chunk of metal and then you have to cut away from it and drill in and whatnot. And this has become really evident in our designs, where we have just complex geometries on the inside of our engine that some of our advisors would look at from NASA, and they're like, I've never seen anything like this before. And that's because these sorts of technologies were never possible. Designing with 3D printing is different from standard manufacturing, because there's a lot of things it allows you to do a lot of new geometries that you were never able to do before, but you're also limited because you have to think it's kind of growing organically. So there's only certain designs that you can do. So as we were designing, we'd send over our CAD models to the guys at MTI, who are very, very responsive to us. They would look at it and say, this right here, this angle right here won't work. That would fall over. I recommend that you switch it up just this little bit. And it was kind of a back and forth iterative process. And we finally just sent over the final model to go get printed. Inconel 718 is a very strong material, which makes it great for the engine. I mean, it holds its material strength up to very high temperatures. And considering our combustion the chamber temperature inside our engine is going to get to 1400 degrees Fahrenheit, it was critical that we found a metal that could support those high temperatures for long durations. I mean, what's really exciting is hopefully one day our satellite's in orbit around the moon, and we get back our first high definition pictures that's from the moon on something that we developed ourselves. Like, I think that is going to be the most exciting thing ever, to have like a background picture on my computer of the moon and know that I developed the technology to take that picture and it's there, and that was me. That's, I don't know, I think it's the coolest thing ever. To MTI, I'm just incredibly, incredibly grateful. They've been so helpful in helping us get to a point where we're at. And again, like I said, this is one of the greatest strengths of our satellite. And honestly, without them, this wouldn't have been possible at all. So they're really have been helpful, and I'm excited to continue to work with them and hopefully develop technology that's really going to revolutionize how mankind gets to space in the future. We're all going to play a very pivotal role in this. It's exciting.